hear a lot of nonsense these days about simulation hypothesis. I think the best way to understand it is to go through history that formed this movement. So let's go through this chart here that starts all the way back in 400 BC and goes till near future. I think physics, biology, philosophy, computer science, and yes, religion are part of simulation hypothesis. So let's begin with 400 BC. There were some religious movements even before that, but we don't know much about it. So the true first properly documented idea that we could be living a dream, I would say Plato's cave allegory and also Chinese butterfly dream idea. Those are the main and oldest ideas that humans came up with. Like, take for example Plato's cave. On the right you see a picture. Obviously, because you saw grass or plants or trees before, you can guess that this is probably a branch with some leaves on it. But imagine a human who lived in a cave and never came outside. Would he understand what he sees if he just sees the shadow of this plant? That is pretty difficult to grasp. He might have all kinds of wild guesses, but he will not know what it really is. Same with our senses in life. We have eyesight, we have hearing, and what we see and sense, that's our understanding of reality. But reality might be completely different, and we don't know. So that is 400 BC. That is a really long time ago. 400 AD. So that is famous Hindus Advaita Vedanta Maya religion or movement. It's hard to define what it is, but it was discovered in Brahma Sutras scrolls, and the idea there is pretty much same, that there is God who dreams and we are part of this dream. Then there is a long jump all the way to 1635, and that is first play, actually, not a novel, by Pedro Barca called Life is a Dream, which also documents this idea of us living a dream, and there is no defined difference between dream and reality. It's very hard to separate those two. My favorite in this period, and if you see on the left, I called it occasional philosophical breakthroughs. This long period in human history is when a lot of smart people, visionaries, thought about this concept and produced these papers or books or plays, like for Pedro Barca. René Descartes is very important scientist and philosopher of those times. He says that if my senses deceived me at least once, how you can trust them? That is, in my opinion, amazing quote from René, and defines it very clearly in very simple words. I highly encourage you to read his whole thing on this. Okay, so that is pretty much this long period of occasional philosophical breakthroughs on this subject. So we move to a much more exciting times. I call this period a quantum physics period because that's a period when we actually understood how weird the physical world really is. And it all started with Thomas Young in 1801 and his famous double slit experiment. What he discovered, and you can see the experiment on the right side, is that we have a duality of particle and wave in all, pretty much in all elemental particles, which is electrons and photons and so on. 20th century begins with a very interesting discovery by Max Planck he defined a so-called Planck constant. Planck constant is a very important constant in physics. It's also a very tiny number. And what it defines is that we cannot measure anything below that constant, neither in distance nor time. So both distance and time cannot be measured below that constant. And that is very fundamental because doesn't it sound similar to pixels? Because that quantifies space in a way. Then 1927, Heisenberg does his famous experiments and comes up with a concept of quantum uncertainty principle. What that brings into this whole weirdness of quantum physics is probabilities, and turns out we have no clue at which moment in time a certain particle is, and that is also fundamental because that means we live in probabilistic world, undefined world. That has huge consequences to all kinds of ideas, including the free will idea. So at this lowest level, free will of humans might be actually undefined in future. So we don't have a destiny, like many say, because even at lowest particle level, we don't know where it is. And we move forward with period that I call a computer-inspired sci-fi. This period is defined by Alan Turing. So as computers popped up, a lot of authors, sci-fi authors especially, they learned about the concept of computer and their imagination started to click and they wrote a lot of books. 1940s, Alan Turing defines the modern computer. Then around that time, Fermi paradox is formed by nuclear physicist Fermi. What he was speculating about is that if we discovered all these trillions of stars out there, even though they're far away, but still speed of light is pretty fast, why we don't receive any signals from intelligent life if all these other star systems have many Earth-like planets with possibly Earth-like life on it and some civilizations. Just probability-wise, it had to happen already, and we should have received the signals, but space so far looks completely devoid of any signals. So are we alone in the universe? This paradox, it is called paradox because there is a contradiction between likelihood of that happening and what we actually see in life. So obviously simulation hypothesis fits perfectly here because we are alone, we are simulated, and we live just because we are the central point here in this universe. 1950s, again, Alan Turing, genius, he comes up with definition of the Turing test, which is a definition of artificial intelligence. And it is still used today to define AI. Also in 1950s, creates the first computer game. Very primitive, tic-tac-toe, but it is a computer game. There were some attempts before that, but a proper computer game would be this one. Again, then, like I said, because of all this computer thing and microchips later, a lot of authors began to write novels, and I would say Philip Dick was one of the first to grasp the idea, and he writes probably the first novel that kind of defines simulated reality, simulated by some kind of machine, and it's called The Trouble with Bubbles, where gods pretty much create these little worlds that they can control, and they entertain themselves with those worlds. This guy also wrote a lot of other books on the topic. Meanwhile, in completely different field of science, molecular biology, Crick and Watson defined the DNA. I mean, DNA was known before, but nobody had a clue what that is really. They actually identified the structure. 1959, the Twilight Zone TV series first, as far as I know, first broadcasted videos about simulated reality. Some episodes have those. Another important novel, Simulacron 3, comes out in 1964. The concepts of simulated world within simulated world within simulated world, so it can be recursive and has many other ideas too. He asks questions like, what is the meaning of life in that context of being simulated, and what does it mean to be human? Meanwhile, again, in completely different field, Konrad Zuse, a German computer physicist person, pretty much starts the concept of digital physics. His book called Calculating Space is a book that essentially speculates that our universe is digital and everything is digitized. First serious scientist, I would say, who wrote a book about that. So then in 1973 we got this German movie, World on Wire. That is English translation, this is a German movie, which we slowly transitioned to modern era. But just before that, I want to explain how important the DNA concept is to the simulation hypothesis. Let's start with Darwin first. So we have evolution, theory of evolution. Yes, that we have enough undeniable proof that happened, the evolution process. We have so many discoveries, archaeological discoveries that prove that. And it's just silly to deny the evolution. What we cannot, though, understand is how the first cell formed. And when Darwin wrote his book, he had no clue how complex that one single cell organism really is. And the complexity is just insane. So how just out of nowhere randomly complex program, which DNA is essentially a program, was formed? That's a mystery, and I think it is a sign of creation there, the DNA molecule. And there are serious microbiologists that actually support that. Even today, there is still no, there's always debate, and majority of scientists still think even the first cell was just formed from essentially chemical processes. But there is a debate right now on that, and this is a biggest mystery. If we can crack that one, that can put many things in their places. So, modern era. I would say for simulation hypothesis, this area is defined by software development and games, computer games, because games gave yet another perspective on simulation hypothesis. And what we see on the left side of the screenshot is same car rendered with textures and without. This concept of viewer perspective is super important, because what it means is that when programmers program the games, we only want to render in high quality, high definition things that player sees. We don't necessarily need to render in high definition or even render at all things that a conscious person doesn't see. So that concept of viewer perspective is somehow interestingly connected to that famous double slit experiment and duality of light, of wave and particle duality of light, because that is kind of fits very nicely together, this concept. Why would we need to render every single particle in this world if you don't see, don't interact with it at this very moment. Again, you can read and watch videos in more details on that. This video is only to give you the historical perspective. 1992, ID Software produces this Wolfenstein game, a 3D game. I would call it a breakthrough because it felt at that time very realistic. And humans suddenly realized that we can go and navigate these virtual 3D worlds, which are very much like our 3D world. And a lot of excitement was brought up by that. From that moment on, we can see that games only got more and more realistic, with VR and IR picking up recently, and so on. Why I included Matrix movie here is because you cannot deny the cultural impact of that movie. In 2003, Nick Bostrom, a real philosopher, publishes his famous simulation argument paper. Now that one is important for two reasons. One is that a serious, you can say, scientist wrote a paper on this topic. And for the second reason is that he did some serious breakthroughs in the thought about simulation hypothesis. 2017, there is a paper published by Caltech PhD people there called On Testing the Simulation Theory. And the idea there is to improve the delayed choice Wheeler's experiment and double slit experiment to prove beyond reasonable doubt that the viewer affects the quant's behavior, and that is still ongoing. I had contacted the guys recently, and they said they still work on these experiments defined in that paper. 2018, Elon Musk popularizes this simulation hypothesis thing by making a public statement. I think it's important if a lot of people start questioning and researching on their own this subject. I think it's very interesting and important contribution from Elon, besides all other things he did. Meanwhile, same year, MIT confirms quantum entanglement, doing research on quasar data. And it proves beyond reasonable doubt that quantum entanglement exists and it's a real thing. Another weirdness, by the way, can only be explained really by simulation hypothesis in a reasonable way, because what it actually says is that two particles, no matter how far away they are from each other, they can somehow affect each other's spin, which is unbelievable concept. 2019, I see a new wave of books, including my own, on subject of simulation hypothesis coming from software people. Well, that's pretty much all I wanted to show you. This is a whole history here again. And if you want to learn about all these aspects deeper, just research on your own. Thank you.